That was weird. Yep, apparently the OBS just decided we were done. Which it crashed directly to login, which is something that only happens on Ubuntu. And when I click back in, we're just gonna have to run the ads here, I guess. When I click back in, Ubuntu was like, "Oh, we gotta update Firefox." I'm like, "Come on." All right. Why don't everybody get up and stretch, and I will be right back. This is going to be a 3-minute ad break. Here we go. All right, we are attempting to, you know what, it might just be even pretzel. Grr. Might be the only issue that we actually have. Okay. So we said that this is y equals x to the 1/2 times c1 cosine plus c2 sine plus 4x plus 8. And I think that is actually, that's what we've got here. Man, without music, this is going to be awful, though. But every single time that we do this, it just decides that it doesn't want to work properly. I don't know what to do. Ooh, there's a snap for it. Alright. Let's see if this works any better. Snap install. Pretzel desktop. There's a truck reversing in the next street. All right, while that's thinking, we're going to come back over here and just double check what we got. Negative 1/2. And it's just sine and cosine of x. Okay. Come on now. Hey. Sign up with Twitch. Because we already do this. Let's go. Really? Just not gonna. Apologies everybody for stalling here, but we'll just be a minute, and or we can keep this going while we look up the password for this, because goodness knows I'm not going to remember it. Really? Oh, that's just freaking brilliant. I already did this. Come on now. Okay, so with this, we want to show that the differential equation y squared double prime xy prime plus x squared minus a quarter y is going to be equal to 4x cubed 8x squared 3x minus 2. Okay, so we could do this individually, which would kind of suck. Or we could do this smartly, which is going to make this significantly more interesting. So since the homogeneous solution includes this stuff, C1, C2, and it's generalized, meaning like it could work with literally anything, then we could say like our solution for this is going to be y equals 4x plus 8, where C1 and C2 are both 0. So if we say y prime is going to be 4, y double prime is going to be 0, then our equation becomes x squared times 0 plus x times 4 plus x squared minus a quarter times 4x plus 8. All right, we're going to trust that the other side is going to be the same, so we'll hang on to it just for a bit. 4x plus, this is going to be 4x cubed minus 1x plus 8x minus 2. So that stuff. And again, get it in order. 4x cubed. Oh. Yeah, 8x squared. Right. Plus 3x minus 2 is equal to, cool, yes. So this, I think, is actually a really good example of a differential equation that's like, the differential equation itself is practically impossible to solve just like by looking at it and trying to work out what the answer is going to be. To try and come up with a solution that's going to work in general, it's going to be real hard. But there are methods that do work on it, and possibly, I mean, it's possible there are some times where like no method will work on it at all. You're just not going to get it. If that is the case, right, then in this particular case, right, we just happen to know an answer that's going to work. We don't have the generalized answer, but we have at least an answer. That's so weird. Come on now. If we run it outside of a shell, does it work any better? It doesn't look like it. It looks like it's failing over and over again. Cool. Okay, so in here, this is going to be the differential equation. Nope, the solution that we get. We want to show that this actually works for p of x is equal to, that'll work. 4x plus 8 for differential equation x squared. Stop it. Oh my god. X squared y p double prime. And in fact, let's do proper differential notation on that. So we end up with d squared p over dp squared. Not quite square, but you know what I mean. Fascinating. Pretzel desktop is not working. I mean, I could have seen this coming a mile away, really, but... If it's not working on the browser edition, right? Why should it work? In a desktop edition. In theory, should work better. X p prime. Oops. That's supposed to be an x on the denominator there. There we go. Plus, minus. No, plus parentheses. Square minus fraction 1/4 times, nope, that's p, is equal to 4x cubed plus 8x squared plus 3x minus 2 Nope. What did I do? Yeah, we're good. All right, so so this is just going to be like a generalized, yeah, like what do you notice sort of a thing. It's not going to be massively like obvious what I'm going for. It's a real awkward way to say this, but would you have been able to find the solutions to any of these without prior knowledge of their solution function types? So like, if you look at A, right, it's going to be pretty obvious that if you've got y prime is equal to a constant times the original, it's like, hey, I know a function that does that. When you derive it, you just get a constant times the original function. It's an exponential function. So that sort of thing becomes obvious. And then the other ones should not be as obvious. Nope, that's a t to the fourth, not an x. Gotta stay with the same independent variable. That's going to be important. For anyone just coming in, my name is Obi-Wan Pez. This is N Simplex Pachinko. We're doing some math tonight, so if you have any questions about mathematics, about education, about all sorts of other stuff like that, you can ask as much as you want in chat. And I'm trying, very unsuccessfully, to get Pretzel Rocks to work for me. Right now, unfortunately, it seems as though my computer is determined to ensure that it does not work. Because I've been trying to get it to sign in. I've been trying to use the terminal version. What is it saying? Hang on. GTK warning. Okay. Setting up IPC channels. User share amdgpu.ids. No such file or directory. That should not be an issue. Deprecation warning. File property is deprecated. Will be removed. Version 5. I don't care. Exiting GPU process due to errors during initialization. That may actually be a problem then. Failed to send GPU control. That might be the issue. That might always be the issue. That might be the issue even when it's just online. Awesome. I can't save the cookies and advertising choices on the first screen. Alright, Pretzel. We're going to have to quit and not use you for now. Too bad. Alright, we'll see if that goes. It'll probably die at some point fairly soon. We'll see if we can just keep it going. I know it was having problems with like Discord also being open, so it's probably just a GPU error, and it's going to be fixed eventually, but I don't know. That's as much as I'm planning on getting out of them here for that. And then 4, what do we want? Ooh, existence and uniqueness might, this might end them. You know, to be nice and all that. That's not it. That's not going to show up as a whole, right? Yeah, no. Okay, yeah. So... Okay. Section 2.3 discusses existence and uniqueness of solutions in nonlinear equations. Cool. So 2.1, 2.2, here we go, 2.3. Alright, separability goes into there. What's our issue here? No. No. You got your verb tenses all wrong because I got like asterisks and stuff like that in there, so you don't know what I'm talking about. Nice try though. Okay. So we're talking about the equation here. Y prime is equal to f of x comma y? Or are we just doing x? X comma y. All right. We omit the proof, which is beyond the scope of this book. Oh, that's nice. Okay. So we have to have y prime equals f of xy, since we can discuss this as being like, you know, this is the slope of this particular function that we're trying to find. Right? So it's going to be like capital F of xy. Capital F of xy. Yeah, that's what I thought. And then we need to also contains the initial condition. That's going to be our point x0, comma y0. At least one solution must exist. Alright, give me 1 minute here. Be right back. Stretch, refill water, all that good stuff. Be right back. Alrighty. Ugh, steel guitar. Okay, so next thing, how might we be able to tell whether a given solution to a differential equation is a unique solution? So there aren't going to be any other solutions. So for instance, D, up that away, 3D, P of x is equal to 4x plus 8 is not the only possible solution to get for that particular differential equation. There was also a bunch of stuff that was attached to it. Anybody who was on that page when we saw it, it's like x to the negative 1/2 times a linear combination of sine and cosine. And any linear combination of a sine and a cosine multiplied by x to the negative 1/2 is going to end up getting you 0 when you plug it into that differential equation. It doesn't even matter what you plug in. So that's like kind of wild. Everybody's like, what are you talking about? So this stuff here, right? It turns out that the full unique solution is y is equal to x to the negative 1/2. See what? Well, we've got it up there. So that one. That's the full unique solution to this particular differential equation that we had. And if we just take the first part, which is also part of there's a special name for it. All the words are running through my head right now, and none of them are correct. When you like put something on top of another. You know, during an eclipse, the sun and the moon. It's not occluding, it's not... Damn it. Superposition, there we go. So yeah, the theorem of superposition is saying that if we want, you could take any linear combination of cosine and sine multiplied by x to the negative 1/2, and then add 4x plus 8, and you will always, no matter what those C1 and C2 values are, you will always get the polynomial that's over on the right there. So that's the 4x cubed plus 8x squared plus 3x minus 2. And for the homogeneous solution, which is the part with the C1 and the C2 stuff, we can actually just say, you know what, I want to test a solution that only has part of it, because like we'll make C2 equals 0, or we'll make C1 equals 0. The law of superposition is saying that any one of those pieces separately is going to end up being a solution to this differential equation. In this particular case, for the homogeneous solution only. So x to the negative 1/2 times c1 cosine x and c2 x to the negative 1/2 sine x are going to be two separate solutions which we could do independently completely and say like, all right, well, we're just going to have the cosine for this one. We're just going to have the sine for this one. doesn't actually matter how much of that solution we use. It's going to always end up working for us. So, and if somebody's like, no, I don't think so, we can show it right here. So we say, let y be equal to x to the negative 1/2 c1 cosine x plus c2 sine x plus 4x plus 8. And again, if we want to just make it the homogeneous solution, just to show that, yeah, actually this other part does come out to be 0 whenever we get it. Alright, this is going to be x squared y homogeneous double prime plus x times y homogeneous prime plus x squared minus a quarter y homogeneous is going to be equal to 0. Again, if anybody's like, no, absolutely not. I was slightly incredulous about this when I first heard it. Like, you must be kidding. There's no way that this is going to work out that way. But here's the thing. When you actually find it, when you're actually coming into differential equations and you're trying to find answers to a differential equation, you start with these like toolkit methods which help you figure out ways of pinning down, like, the solution has to be of this particular type. And then once one of them gets placed and say like, okay, this one has to be x to the negative 1/2 times cosine, the other solution automatically gets locked in as x to the negative 1/2 times sine. So there's just certain behaviors, certain pairings that absolutely have to work together. So if we come in here and we say, okay, we're going to take x squared y homogeneous double prime. Nope. Y homogeneous is going to be that thing. Y homogeneous prime. It quite a night. Is going to be negative 1/2 x to the negative 3/2 times c1 cosine x plus c2 sine x plus x to the negative 1/2 multiplied by, this is going to be a negative c1 sine x plus c2 cosine x. Right, we use the product rule. Split this out, and then y homogeneous double prime is going to be very inconvenient, but nonetheless, take the derivative out front. This is going to get you a positive 3/4 c1 cosine x plus c2 sine x minus a 1/2 x to the negative 3/2 multiplied by, and then we get the same middle part that we had in this part here. So negative c1 sine x plus c2 cosine x okay, and then we go the other way. Start with here, take the derivative of that bit. That's going to get us a negative 1/2 x to the negative 3/2 negative c1 sine x plus c2 cosine x Okay, and then plus x negative 1/2 times the quantity. Right, now we take the derivative of the inside of this stuff, so negative c1 cosine x minus c2 sin x. Alright, now we try to simplify. This is going to be gross. This should have an x to the negative 5/2 on the outside first. Okay, so y homogeneous double prime is equal to, this can be a 3/4 x to the negative 5/2 minus, what we can do is take the negative out of here, move that out front, so x to the negative 1/2, all that stuff times c1 cosine x plus c2 sin x. Alright, these two terms here are the same, so we're going to factor out that middle stuff. I mean, it's the same thing. So, right, that's going to be a negative 1 x to the negative 3/2 times negative c1 sin x plus c2 cosine x. Okay. Sure, that'll work. X squared times 3/4 x to the negative 5/2 minus x to the negative 1/2 multiplied by c1 cosine x plus c2 sin x. Okay, that is in brackets because we also need to add in the other thing. Right, negative x to the negative 3/2 parentheses negative c1 sin x plus c2 cosine x. Ooh. Oh, it's gross. Right? Got all that? Yeah, looking alright. Okay. Then the differential equation says we're going to take that and we're going to... Nope, we're right there. X times y prime. So the prime version is here. Top right. Negative 1/2 x to the negative 3/2 times c1 cosine x plus c2 sin x plus x to the negative 1/2 times quantity negative c1 sin x plus c2 cosine x. Looking good there. And then lastly, what's that? Plus x squared minus 1/4 times y. So our y is x to the negative 1/2 c1 cosine x plus c2 sine x. We want all that stuff to be equal to 0 at the end. Dear all that is holy, this is going to be a mess, but it works. So I'm actually still going to keep all this separate, keep all of our like sine and cosine stuff together, and keep all of our polynomial stuff together, and see if we don't have to multiply everything in. So, spoiler, I'm pretty sure it's going to work just fine. Just a hunch, you know. Okay, so in here, we're saying that all this stuff is then going to be equal to x squared multiplied by all that other stuff up there is going to get us a 3/4. Right, x squared is the same as x to the 4/2, and we're going to multiply that to x to the negative 5/2, so this is going to get x to the negative 1/2. Okay, and then same deal, minus x to the 4/2 minus 1/2 is going to be 3/2, although this is in the positive direction. And also, we see this down here as well, and down here at the bottom as well. So we can actually combine those things and say, okay, we're going to get, in addition, the one from the middle is going to have x multiplied by negative 1/2 x to the negative 3/2. So this is x to the first times x to the negative 3/2 is going to be x to the negative 1/2. So it's going to be minus 1/2 x to the negative 1/2. And then all the way at the bottom, we've got here, this can come back out here. Multiply that, x to the second times x to the negative 1/2. Right, that's going to be a positive x to the 3/2. Nice. Minus 1/4 x to the negative 1/2. Right, all of this is then multiplied by c1 cosine x plus c2 sine x. And if you look real careful, right, negative 1 x to the 3/2, positive 1 x to the 3/2, those are gone. Right, 3/4 x to the negative first, minus 1/2 minus 1/4. So negative 1/2, negative 1/4 is going to get us negative 3/4, and we have a positive 3/4. So all three of those are gone too, which just gets us a big 0 for this entire set. Okay, then we have to get the other one. So the other stuff, all right, plus, can't say it's behind my head, that's fine. Here we get an x squared times negative x to the negative 3/2. Again, that's going to get us an x to the positive 1/2, but it's negative. Next one we get x to the first times x to the negative 1/2 is going to be x to the positive 1/2. And that's it. So this is a negative c1 sine x plus c2 cosine x. And again, it's going to be 0. So 0 plus 0, we do end up getting a 0. This verifies that anything in that solution, right, any part of that solution, C1 and C2 just being generic, is going to cause us to be able to have this homogeneous solution, which always ends up getting us 0, no matter what the values of C1 and C2 are, which is just really cool. Alright, so no matter what C1 and C2 are, if we plug it into this differential equation, we get 0 for it for all of those possible values, which means that when we go back all the way up to the top here and we say what our total solution for this was, right, y equals x to the negative 1/2 times c1 cosine x plus c2 sine x, that piece is always 0 plus 4x plus 8. Take that 4x plus 8 part, that's not going to be 0. Plug it back into the equation that we have here, and again, the stuff on the left, all of our y's, y prime, y double prime, ends up getting us this 4x cubed plus 8x squared plus 3x minus 2. If we plug in 4x plus 8 as the y function. And again, if we had plugged it in with all the rest of the stuff as well, the law of superposition tells us that we're going to get the same thing, whether we do just the 4x plus 8 part or the 4x plus 8 plus all this other stuff with the C1 and C2. Because again, this is always just going to be 0, so of course it's going to be the same. Add 0, nothing changes. Alright, how might you be able to tell whether a given solution to a differential equation is a unique solution? So in here, boy. Okay. Okay, so let's go through the uniqueness theorem here. It may happen that b is less than infinity and all solutions have the same values on a and b, a to b, but two solutions y1 and y2 are defined on some interval a to b1, with b1 being greater than b and have different values for b, well, different values for x between b and b1. Thus, the graphs of y and y2 branch off in different directions at x equals b. See 237 and 233. Determine the largest open interval on which this thing is unique. That's actually a good way to do that, right? Oh, we don't have a 237 here. Interesting. Oh, or in example 237. Yeah. Okay. Solutions of the initial value problem that differ on every open interval that contains b. Therefore, f or f partial with respect to y must have a discontinuity at some point in each open rectangle that contains by prime or y bar, which is the common value. Since if this were not so, 232 would have a unique solution on some open interval that contains b. Okay. 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 So there must be a unique solution on an interval a to b which contains x sub 0, the initial value, or else either the function itself, which is our essentially slope differential equation, or the partial derivative of f, our slope function, in the y direction or with respect to the y direction has to be discontinuous. I'm not sure I can explain that 100% satisfactorily. We'll have to worry about that later. But at any rate. Alright. I think we're going to probably rate out. And I'll stick around online for a bit. We're going to go oversee Don Does Math, who, by the way, recently got Outer Wilds, and he is going to be doing an Outer Wilds stream, I believe, on Friday. So if anybody is interested in doing or in watching Outer Wilds, I do highly recommend. If you have never played it yourself, you're going to want to play it. If you're like, absolutely not, I don't like this, but I like watching other people watch it, or other people play it, you could do that too. You know, do your own thing. But if there is even a slight chance that you want to play Outer Wilds, and I highly recommend anybody who likes discovery, puzzle, challenge-y type stuff, like, definitely play it yourself. At any rate, I will see you probably on Friday for gamey type stuff until Don starts playing Outer Wilds, or maybe a little bit into his stream. We'll see how it goes. My name is Obi-Wan Pez. This is N Simplex Pachinko. We'll see you later.